Hi, welcome to JMonkey 3D Game World. Our team number is 19. So here we are implementing 3D game in JMonkey, which includes animation, sound effects, visual effects, and with the camera. We are presenting in best way possible. This is our task board for Sprint 1, which includes the activities assigned to each member of the team 19. This is our burn down chart for 4 weeks, that is Sprint 1. So this is our Kanban board for Sprint 1, which includes tasks for done and tasks in progress. In progress, we will be implementing for Sprint 2 and the tasks in done, which we have implemented for Sprint 1. Hi, myself Surabhi. I am working on background feature which includes nice grass, hills, water, etc. Activities assigned in task board to me are setting up scene and creating terrain has been implemented. The following is the code which implements setting up the scene and creating terrain. So now I'll be running the program. Click on continue. So this is my output with the nice grass hills. So for coming sprint 2, I'll be extending the feature with more enhancement like with the water, sky background, etc. Thank you.
Hi, this is Neeti, and I'm working on the audio effects for our project. The activities assigned to me, as seen in the Kanban, is to implement the audio features for our project. Basically, I'm implementing three types of sounds, that is, the forest sound playing in the background, gunshots, and footstep running parallelly. For this, I have used a new method called init audio for implementing the sounds, and I've used the sound types of format .ogg, which is placed under the sounds folder. In the audio node, the first thing that we implemented is the forest, which is a buffered node. And all the 3D sound effects for this are switched off. And the same is done for the gunshots, except that gunshot is set to run in a loop. And I'm starting the gunshot sound after an offset of 0.5 seconds. And the same implementation has been done for footstep as well. And my aim is to provide the sound effects on occurrence of each character on screen and also the implementation or the integration with other modules of our project. So this is the output of my implementation.
Hey, this is Anand for team number 19. I represent the graphical content associated with the characters in this project. In order to bring to life the characters over JMonkey, I used the Blender application to design the characters and render them. At this stage, the characters which are created is the gumball machine in an enclosure. It consists of a UV sphere, a cylinder, and another wider cylinder, a spotlight, and a camera. The material that is being used here is different in each case. The sphere consists of an image texture along with the diffuse BSDF color, and the cylinder consists of a glossy look and the color blue. the rendered look would look like this. I did spend a considerable amount of time exporting this to JMonkey. I had to download an add-on to Blender application, that is the Ogre XML, and once that is done, I import it to JMonkey through these files. In order for the project to be executed. I use the JMonkey. It needs a bit of light. And this is the different perspectives on the object. The implementation with the other characters is the next step to the final showdown, ending with sprint number 2. Thank you.
Hi, this is Asa, and I'm working on the effects in JMonkey. I will be working on how to introduce various effects into a project. As a part of Sprint 1, I created a couple of effects in JMonkey. First class I added was referenced from the internet, and it's a basic hello world type of application. It just creates an element and displays it on the screen. I then went on to create the hello fire effect. Here I learned how particle emitter works. I created a simple particle emitter called fire and initialized various properties, like I set the texture to flame and the material, and then also the end color, the start color to red and yellow, and the start size and size, what the gravity will be, and what is the low light, highlights, and various different properties. On running this class, class, you can see that there is a fire and it's emitting some particles. I then went on to create implementer. Is the next class, which is the blast. In the blast, there's first a fire created, again using the particle emitter, and then we create a blast. We then create embers which come out, and sparks, and the debris which is left behind. So I'm going to go ahead and run this class. As you see, there's a blast and fire debris and embers coming out. So as a part of Sprint 1, this is what I did and learned. As a part of the main project, I will be implementing various effects for the game or the end result that we wish to achieve. Thank you.
Hello everyone, I'm Arvind, the cameraman. So I worked on creating a dummy character and I implemented the chase camera. Normally the JMonkey platform uses the fly cam, which you have to move the camera using the WASD keys. But in chase camera, it is based on the spatial movement. It is based on the objects that are attached to the root node. Whenever an object moves, in a sequence, the chase camera automatically moves along with the character. So here is the code that I implemented. So I created a character and I assigned the camera to him, and I disabled the fly cam. We'll see a quick demo. Run the file. So here you see the red little thing character. So as and when I rotate using the mouse, the camera, the origin is pointed at the axis 0, 0 and 1, and as and when I move the camera based on this point, origin point, keeps moving. I can even zoom in, zoom out and zoom in. So the next sprint you will see this red little creature more colorful with running in a terrain as already seen by shown by my colleagues. So I'd like to highlight some of the key learnings in this sprint. So the highlights are the most important what we learned is the time management, and we were to a certain extent successful in defining the task more clearly in the task board. However, for the next sprint I think we should have a better one, and maybe this sprint we saw a little bit of lack in the unit testing, which we would really want to improve in the next sprint, and this would help us in the faster integration and even easier integration. So stay tuned for the next video. Thank you.